Which of the following statements is incorrect regarding the myelin sheath? So remember what the myelin sheath is. So if you have your neuron goes there, and then remember you have your axon, which is the long tail at the end, which transmit electrical signals from one neuron to the next. And then sitting on the axon are these, they kind of almost look like bumpers, like maybe what you see on the lane in a pool. All right, so these bumpers that are on here, these are the myelin sheath. And think of the myelin sheath sort of as a slide. So if you think also maybe if you're in some sort of a video game and maybe there's like a race course like here, and then sometimes you might hit like a section there where you go through that race course and you start to speed up really fast when you go through that section. And that's kind of like how the myelin sheath works. It helps the action potentials or the message to transmit faster. And if someone has some sort of a disease where this starts to break down, then the messages will be slower, and then they'll start to have neurological deficits based on not having the myelin sheath that's needed for the message to be successful. So now that we understand what the myelin sheath is, we could help to understand what would be incorrect when we go through these choices for the myelin sheath. So it's important to note that the myelin sheath, while it acts like a slide, that it's a process called saltatory conduction. And we could see saltatory conduction is listed in option A right here. This is referring to the action potential where it jumps between the gaps. And this is in the sheath called the nodes of Ranvier. So when we're talking about this speed up process as the message is going through the myelin sheath, that is referring to the saltatory conduction. So therefore option A is looking correct, but we're looking for which is the incorrect option. So we could eliminate option A. Option B is saying that the myelin sheath is responsible for increasing the speed of propagation of action potentials, which is correct. That's what we were describing about how the action potentials and the messages, they move along faster because of this myelin sheath. And since we're looking for what's incorrect, we could eliminate option B. Option C is saying that the myelin sheath thickness is directly proportional to the speed of the action potential propagation. And this is correct because the speed is, in fact, much faster when the myelin sheath is thicker. So going back to the example, if someone has some sort of disease such as multiple sclerosis where this sheath is breaking down, it'll become less thick and therefore the message won't be as quick. And then looking at option C here, when it's saying directly proportional to the speed of the action potential, then yes, in fact, if it becomes thinner and wear down, then the message will not be as quick. And therefore we could eliminate option C because we were looking for which is incorrect. Lastly, option D says that the myelin sheath is made up of oligodendrocytes in the PNS and Schwann cells in the CNS. So be careful, this option is a little tricky because when we look at this option, we see oligodendrocytes and we see Schwann cells. And that is true that both of these things help to make up the myelin sheath. But be careful because it's saying that the oligodendrocytes are in the PNS and then the Schwann cells are in the CNS, but it is actually reversed. The oligodendrocytes are related to the central nervous system and the Schwann to the peripheral nervous system. So make sure if you're using this slide to study that you have this written down in your notes the opposite way. So remember that you have your oligodendrocytes is related to your central nervous system and that your Schwann cells are related to the peripheral nervous system. And that leaves us with option D because the question is asking which is incorrect.